Welcome to the fifth module. In the previous module, you learned all about single arrays and the different ways they were useful. But sometimes you're going to want to work with multiple arrays of the same size and data type. Here in this module, you'll accomplish that. We'll be discussing what there is to know about two-dimensional arrays and their functionalities. You'll learn how to declare them, the different ways of initializing them, how to process the contents of two-dimensional arrays, and how to use them as arguments. A two-dimensional array is a set of identical arrays working together, convenient for using multiple sets of data at a time, where they are all the same data type. A regular array only has one declarator, and it's for the size of the array. In a two-dimensional array, there are going to be two sets of brackets, each with a size declarator. If we were to look at a two-dimensional array as a matrix, like in the table shown below, the first size declarator would represent the row and the second the columns. And to access a specific element, we're going to be using subscripts again. Remember that subscripts start at 0. If we want to access the first row, we would leave the first set of brackets with a 0 and increment the second set of brackets, starting at 0 and ending at 1 less than its size declarator. If we wanted to access a row, then we'd leave the second set of brackets with a 0, and we'd increment the first set of brackets starting at 0 and ending at 1 less than its size declarator. In this program, we're going to enter a student number and the grade of their past 3 exams. First, two constant integer variables are created. Variable row initialized with 4 and variable column initialized with 3. Then a two-dimensional array of type int is created using row as its first size declarator and column as its second. Next, we're going to input values into the entire array. At this point, you can choose whether you want to go column by column or row by row, entering the values. In this case, I'm going to go column by column, entering the numbers shown in the program output. As you can see on line 12 to 15, I left the second set of brackets at 0, while the first one incremented. Next, I incremented the second set of brackets by 1 to have access to the second column, and I incremented the first set of brackets again from 0 to 3 till it was completely filled. Finally, for the last column, the subscript in the second set of brackets was incremented one more time, and the first set of brackets had its Remember that there's two size declarators, and the first size declarator is for the rows and the second is for the columns. When you create a two-dimensional array, the first size declarator is the number of arrays you're creating, and the second size declarator is for the size of the arrays. You'll see on the top left a group of arrows pointing at the 4 different arrays. These are saved consecutively in order in memory. Watch. In two-dimensional arrays, there are no boundaries checking either. So if you're entering values in the first row and you accidentally enter a subscript for 3, it's going to enter the next space in memory, which is actually the first column on the second row, and you'll overwrite that. Now a moment ago, we saw how you enter values manually going one by one and changing subscripts. Well, to enter all the values again using a for loop, it would look exactly like this here. Now there's two loops, one of them nested inside the other. The first for loop will be for the first In this program, we're going to initialize three different arrays. First, I declared four constant integer variables. First trimester initialized with 3, second trimester initialized with 4, third trimester initialized with 5, and students initialized with 3. And then on line 12, I've declared an integer variable called numbers with students in its first set of brackets and trimester in its second set of brackets. To initialize a two-dimensional array, the first option is to initialize it like you would any other array. For this example, I used the number 1 through 9. Remember that they are separated by commas and placed inside a set of braces. And in the top right table, you can see how they've been placed in order by rows. Next, on line 15, I declared an integer array called values, with again students as the first size declarator and then second trimester as the second size declarator. This time, the initialization has been modified to be more understandable. What I did here was that I encased the first row in another set of braces, I encased the second row in its own set of braces, and the third row in a pair of braces of its own. Still, all numbers separated by commas and inside another pair of braces, and the array would ultimately fill up like the center right table. Lastly, on line 18, I've declared an integer array named digits, with students as its first size declarator, and third trimester as its second size declarator. In this one, the way the array has been initialized has been done to look like the table. The rows are once again encased in their own set of braces, and they are placed one underneath the other. This way, it is a lot easier to visually see how it's being initialized. But this array is partially initialized. We'll notice that in the first row, only 5 values were entered instead of 6, so the 6th value will be initialized with a 0. And for the second row, only 4 values were entered, so the last 2 will also be initialized with 0. Partial initialization can only be done by row if encapsulating the braces by row. Otherwise, you'll have to manually enter the value 0, because if you just place two commas next to each other to symbolize that nothing is there, it will result in an error. When passing two-dimensional arrays as arguments, in the function call, you'll pass only the name of the array as it contains the address of the first element and the variable used for the rows, not the column, and the compiler must know the size declarator of the second bracket before reaching the prototype. At the beginning of the program on line 5, you'll notice a global constant variable called column initialized to 5. This is going to be used for the second set of brackets of the two-dimensional array being passed. Next, in line 6, there's a function prototype with a return type void called getGrades, with its first argument receiving a two-dimensional array of data type integer. We know it's a two-dimensional array because it has two sets of brackets. And remember that the compiler must know the size declarator of the second set, so column has been placed inside. In the following line, there's another function prototype called averageGrades, also with a two-dimensional array in its parameter list, and then an integer variable and a reference double variable. To get a quick overview of what this program does, it's going to get the student number and the last 4 grades of this student, and then the program will calculate the average grade between all the ones entered. On line 11, there's a two-dimensional array of type integer declared with 3 rows and 5 columns to hold the student numbers and their grades. Then a double variable called average is being declared to hold the average of the grades. Next, there's a call to function getGrades with the two-dimensional array students being passed and the variable row. Skipping to your right-hand side on line 34, there's a double for loop that is going to first iterate through j being the columns, then I increments and j iterates again till 1 less than its size declarator till the entire array has been filled. Two-dimensional arrays, like one-dimensional arrays, are also referenced, so the values entered will also have the same effect on the original argument. To see the values entered for this example, they are in the program output on the lower right-hand side. Each row contains a student number followed by its 4 grades. The program then returns to where it was called, and on the following line 15, there's a call to function averageGrades with the two-dimensional array students as an argument, with row and average also as arguments. AverageGrades will get the average between the grades. To do this, we need to skip the first element of every row, that is the student number. So in the nested loop on line 45 of this function, we're going to initialize j with 1. Then we have a variable type double initialized with 0 that's going to hold the sum of all the grades as the for loop iterates through the entire array, without including the first element of every row, that is the student number. On line 47, we have a count variable that was previously initialized with 0. This is a counter variable that will always increment by 1 with each loop done to count the total number of grades that have been added. On line 49, we then divide the sum of all the grades that is inside the variable total with the variable count and assign the result to the variable average. Then, returning back to its caller, the program continues on line 17 to print all the student numbers and what their average was. And on line 21, there's another message that prints the student numbers and the grades entered. And with this, the module on two-dimensional arrays is concluded.